In our project, we investigate spatial temporal patterns of NO2 level and human mobility through the variants of COVID-19 in Southeast Asia. And this is the web app to visualize NO2 and its influential factors in Southeast Asia from 2020 to 2021, which was created and deployed using Streamlit, written purely in Python. And if you want to know more about our study, here is the story map where you can take a further look, or you can go to our GitHub repo. If you have any suggestions, you can just put a request. Okay, back to our app. So in the home page, we can see some, we can download the data, and also we can take a look at the data by sorting them to a particular parameter. If you're not sure what does it mean, you can see some explanations of each parameter. And here shows some demo of how to use different apps. And below shows some visualization examples. So all of them can be obtained using all these maps. For example, here's what we can do using timeline app. This shows the mobility change with time, and the color shows the NO2 levels. And also try to map one or two variables like this. And here shows the scatter app, so we can plot y versus x, and also use color to represent another example. And we can also select the countries we are interested or not interested, or zoom in anywhere we feel very interesting. Yeah, so like this. And also we have the 3D app, and also train your model. In this timeline app, we can first choose the y variable. So in this case, we are using the Facebook movement, and in general, we can see how it changes with time. We can see it drops, and we can also zoom into the countries we want and select or unselect them. And also, we can use the color. So we can choose another variable that is represented by color, and in this case, we are using Chen-Chieh index, which shows how strict or how tight the government measures are, which will affect the mobility level. And also the size can be represented by NO2 or any other variables you are interested in. And this shows the plots for different countries. And also we can take a full look in one country, and this is Indonesia. This shows the map app. We can see we can choose the color. In this case, we are using NO2 to represent the color. And if you also want to include another variable to set as size, you can click this, and so you can choose which one you want to set as size. So in this case, I will be using the Facebook movement, and we can choose the maximum size we want. This shows the scatter map, in which we can choose X variable and also Y variable. And at the same time, we can set color as a variable. And yeah, so in this case, we are using Y as the NO2, X as the Facebook mobility, and the color represented different countries. And similarly, we can also choose the countries we want or we don't want. We can zoom in, zoom out the areas we are more interested in. At the same time, we can also change the chart type. For example, for here, I don't want rug, I want violin. So you can see now it becomes violin plot. And if you are interested in some points, you can also zoom in here. This shows the 3D map app. So in this app, we can choose the months we are interested in. And then the elevation will show the Facebook movement and the color in NO2 level. As mentioned, we also create a model where you can do some data analysis. In this case, you can train a machine learning model. So for example, we are using 8 hidden layers, and we are using 64 nodes, and the batch size, I will set it to 1000. And then for the number of iterations, I use 20 first. And I also want to see how to explain the model. So I click here, and I will use 1000 data to explain the model. So we can just start training. Yay! And then we can see the results. The minimum loss, the validation loss is about 0.08. And you can clear the histories and change the parameters here and try to train again. But I think this is good enough. And when you feel it's good enough, you can take a look how different parameters impact the output in this model. Yeah. Okay, that concludes our brief intro to these web apps. And in general, there are 4 apps for visualization and 1 app to train your machine learning model and to see how different factors impact in the output NO2. And if you are interested in the source code, you can go to the GitHub repo. And all our codes are open source, so you can take a look. Also, if you want to run it locally, you can just clone this repo and then copy the code and run it locally. Thank you.